Warm welcome everyone to the next episode of AOS-CX 10.12 update series. I'm Shobna, Technical Marketing Engineer, Aruba Campus Switching. So in this episode, we'll see about one of the new addition to our AOS-CX switching feature set, that is device fingerprinting, in short DFP, integration with our Clearpass Policy Manager. So let's jump into the session. Here is the agenda for today's session. We'll be covering following topics. First is the overview. Next, the use case this feature is trying to solve, details and caveats of this feature, how to do the configuration, best practices to be followed for this feature, demo of how a feature works, and any additional resources required for this feature. First is overview. So before we understand this feature, let's study about the background behind these enhancements added in our AOS-CX switching software releases. Customers today are dealing with following challenges when it comes to client identification and monitoring. First is poor visibility. So IT teams are often unaware when, where, and what type of end clients are being connected to the network and rely on admin to accurately onboard clients. So the lack of visibility can leave organizations vulnerable to security and risks. Next is increasing complexity. So most client profiling solutions available today require the installation of additional collectors and agents, and provisioning the collectors across a distributed deployment is neither cost effective nor scalable. Additionally, only about 40% of the IT teams have set well defined access policies for IoT devices. Last is manual security processes. So, once clients have been identified, automated monitoring and policy enforcement are required to reduce the need for manual intervention. So, without that, IT teams will have to rely on manual processes to assign rules, track, and enforce behavior. This will result in inefficiencies. So, these challenges led to the development of Aruba's Zero Trust Security Framework. So, it is designed to better address the changing security requirements for modern organizations. So, the Zero Trust Framework improves the security posture, prevents the data breach, and limits the lateral movement on the network. So, here are the five pillars of Zero Trust Security Framework. Foremost is visibility, next is authentication, then rule based access control, continuous monitoring, enforcement, and response. So, in this session, we'll see how the first three pillars are achieved using DFP, that is, device fingerprinting, Clearpass integration. Device fingerprinting overview. The device fingerprinting is a feature in which the switch collects the protocol data sent by the end devices, and then the analyzer consumes this data to fingerprint the device. So, this solution consists of two parts. The first component is collector. The Aruba CX switches will act as collectors and switch monitors various protocol traffic from end devices and extract specific information from these packets based on the user configuration. So, the information collected from the end device will be sent to the analyzer for further analysis and profiling. So, in current release, the device fingerprinting feature monitors the DHCP, HTTP, LLDP, and CDP traffic from the end devices and extracts data from these protocols based on the user configuration. The information collected from these devices may include like type of the device, type of vendor, the operating system of the device, and version of the operating system, etc. The next component is analyzer. So the DFP data then used by the analyzer to fingerprint the end device that can be further used to set the network access policies based on the details of the device such as the vendor or the operating system running on the device. So example of analyzer in our Aruba portfolio or Central and then the Clearpass. As discussed earlier, the main purpose of device fingerprinting is it helps to categorize the devices by analyzing the data sent by the end devices. So let's see the history of its support in our Aruba switches. The DFP got introduced in our CX switches in 10.8 release, but till 10.12 release, Central was the only analyzer used by the Aruba CX switches, and hostname is the only attribute the Central was pulling through REST API from the CX switches. So 10.12 onwards, we have Clearpass support for all the DFP attributes using radius accounting. So let's see quickly how it does. If end client sends any DFP related packet, the switch will be sending the DFP data to the Clearpass policy manager using a radius accounting packet. The radius accounting packet will now carry the DFP data. So let's see the use case. So the major usability of this feature is better visibility. Like when a specific device is fingerprinted, the details can be used to provide control network access for the end devices by Clearpass. So the administrators can create appropriate access and enforcement policies in Clearpass during authentication. For example, devices which are fingerprinted as computer will be given access to specific VLAN, and devices which are fingerprinted as phones will be given access to the voice VLAN. So now that the client's identity is known without additional network collectors or probes, because the switch itself will act as a collector and our own ClearPass policy manager as analyzer. So this visibility will help Aruba's dynamic segmentation solution for end-to-end secure network access. So far, we have seen the overview and then the use case this feature is trying to solve. So let's see the advantages of this feature compared to the traditional device fingerprinting integrations. So here is the list of commonly used traditional device fingerprinting integrations between the NAC and then the CX switches. The first is DHCP, where the DHCP discover packets from the clients will be relayed to the ClearPass for profiling. Next is SNMP probe. So the SNMP query request to get the end client details using LLDP MIP or CDP MIP from the switches. So here are the overhead involved in these traditional methods. First is additional packet exchange. So in case of DHCP based device fingerprinting, the DHCP discover packet from the inclines every time must reach the NAC for fingerprinting besides the dedicated DHCP server. So we will configure ClearPass as additional helper address apart from the dedicated DHCP server address either in the access switch or in the code switch based on the network configuration. Hence, it creates additional DHCP packet forwarding to ClearPass. So in an enterprise network with vast amount of end devices, so these packets will consume the network bandwidth and overload the ClearPass as well. So thereby reducing the performance of ClearPass. Same additional packet exchange applies to SNMP probe as well. Apart from that, in case of SNMP probe, there will be a probe delay because it can happen only based on the configured SNMP probe interval in ClearPass. So radius accounting based device fingerprinting is gainful since the existing radius accounting packets will be reused for sending the device details and will be resourcefully handled by the ClearPass as it is already processing other radius accounting packets and attributes effortlessly. Details and caveats of this feature. So let's hear about the DFP workflow with following entities. So we'll have an incline connected to the port access security enabled port in access switch, and access switch over the uplink is connected to ClearPass. First, the end device once connected will send any packet to onboard. Since security is enabled on that port in access switch will send a radius request. But ClearPass does not have any details about the end device, so the radius response will be to place the client in a quarantine role. Now in the quarantine role, the device connected port is opened with minimal access as per the role configuration. And to account the client authentication, we will send a radius accounting start message to Clearpass. So after that, when we receive any LLDP, CDP or DHCP or HTTP packet from the end client, we will use it for building the DFP details. Then this learned DFP data will be sent to the Clearpass in a radius accounting interim packet immediately in the form of a DFP VSA. So the Clearpass will update its endpoint repository with these details, and now Clearpass is aware of the device detail using this DFP data. Hence, Clearpass will initiate a radius change of authorization message to switch. So switch can bounce the client connected port. So once the client connected port is bound, later on the switch onboards, it will be placed in the device specific rule after a radius handshake. Hence, the DFP integration with Clearpass is really helpful in device visibility and then the profile enforcement. Details and caveats. So this feature works only for a port access client, that is a .1x or MAC authenticated clients. The device fingerprinting information for an authenticated client is gathered from protocols such as LLDP, DHCP, CDP, and HTTP and sent as radius accounting interim package to the Clearpass. So here is the prerequisite for this feature. The client device fingerprinting feature must be enabled on the interface, and for sending the radius accounting interim update, we need to enable the radius accounting interim update feature. So there may arise a question, how do we send this DFP data to Clearpass in a radius accounting packet? So for that purpose, we have introduced a new VSA, the Aruba AV pair VSA. It is of length 247 characters and type string, and it's a Aruba specific attribute, and then the unique ID is 67. Supported platforms. So this feature is supported in following platforms: 6400, 6300, 6200, and 4100i. So other point to be noted is DFP has been enabled in the 4100i platform from 10.12 release onwards. Next is this feature is supported for IPv6 deployment as well. So both the client and then the server, that is Clearpass Policy Manager, can be IPv6. So let's jump into the configuration. So let's see the configuration required for this feature integration. So we need to associate the Clearpass radius server group to a radius attribute group. In that we have to mention for this group the VSA has to be sent. So here is the syntax for that AAA radius attribute group, and then name of the radius server group where the Clearpass is present, and then the VSA enablement. So here is the series. VSA vendor is Aruba, type AVPAR, and group is DFP client info. So to view the configuration change, we can use the show running configuration along with the filtering the radius attribute. So let's jump into the best practices. So here are the best practices to be followed for this feature. First, Clearpass is the only supported NAC currently. So we do not have the support for other third-party NACs because it requires additional efforts from the other third-party NACs for understanding this Aruba AV pair VSA. So next is it is integrated only in following Clearpass releases, that is 6.11.4 release onwards. Next is DFP integration feature will send only the recent change of the DFP attributes, not the history of it. If there is any update to the DHCP option, only the recent will be sent to the Clearpass Policy Manager. Next, in case you are moving to this feature compared to traditional methods, then it is recommended to remove the traditional DHCP based profiling configurations from the switches. So let's see a demo of how this feature works. So here is the topology I'll be using for the demo. It's a three-layer topology with access switch connected to aggregation to the core and then the Clearpass policy manager. I'll be using two clients for this demo. One is the AP and other one is a phone. So here is the simplified configuration required for this demo. I have created a device fingerprint profile, and this profile will be able to gather the DFP data from LLDP, CDP and DHCP packet, and I have created a DDS server and associated that server to a DFP Clearpass group. So this group will be used for servicing the .1x and MAC authentication requests, and it has been enabled with the DFP VSA assignment as well. So apart from that, this radius server has been enabled with DIN authorization request. So let's see the port level configuration. As part of our Aruba dynamic segmentation solution, I wish to make sure these ports are colorless ports. So for that purpose, all the ports will have the similar configuration. So here is the configuration. .1x and MAC authentication enabled with concurrent onboarding, and I have applied the device fingerprint profile TFP1. And for sending the accounting updates, I have enabled the accounting update CLA as well. So let's see what is the role assignment for these inclines. So first for the AP, I'll be assigning a AP rule with auth mode as device mode and POA allocate by class. The next for the phone. For the phone, I'm trying to apply a voice VLAN and then POA allocate by usage. Let's jump into the demo. So here is the switch console. First, let us validate the switch version. It is in 10.12 version, which will be supporting the DFP integration. Let's check the client connected ports configuration. So the third port is connected with the AP, and then the fourth port is connected with the phone. So both these ports will have similar configuration. It is a colorless deployment. So let's check the client connectivity using LLDP. So the LLDP neighborship is learned for both the ports. Let's check the details. So we'll use a show LLDP neighbor info and then the port specific show command. So it clearly states it is a Aruba IAP and then the model. Next for the phone port. Here also evident it is a phone connected to that interface. Let's jump into the Clearpass configuration now. So I have created a MAC authentication service here. So I'm using the Clearpass version 6.11.4. This is the version that will be supporting this DFP integration. So let's go to the profiler and authentication tabs. First is authentication tab. So here I made sure I'll be using the authentication source as endpoint repository. And then in the profiler, I have enabled COA. So in case of any category OS family or name change, then a COA action will be triggered. The COA type to be triggered is a switch bounce port. And then we'll go to the enforcement tab. Here in the enforcement tab, the default profile I have created is a quarantine profile. If any of the conditions below is failing, then the quarantine profile will be applied to the incline. Next, device specific enforcement profile I have associated. Like for AP, AP DUR, for a phone, phone DUR, for a PC, the PC DUR. And in case if the end client is not profiled, then I'll be placing the end client in the quarantine DUR profile. As we have seen, only from Clearpass version 6.11.4 this DFP integration supported. Let's check whether how we can identify the version support. So we can go to the dictionary file of Aruba and then check whether this Aruba AV per VSA is present or not. So this is the VSA that will carry the DFP data from the switch and it will be interpreted by the Clearpass policy manager. So let's consider the inclines MAC addresses here, AP and then phone. First, we'll go to the endpoint repository and check if these devices are learned. And if you could see here, the devices are not learned. So we'll check for the AP now. Already we have checked for the phone. So the phone is not available. Let's confirm for the AP as well. The AP details also not present. So this is the fresh deployment where the incline details is not available in the endpoint repository. Now we'll go back to the switch console. So we'll try to toggle the client connected interfaces. So what I'm trying to do is in other console, I will run the show port access client show command repeatedly to check how the clients are getting onboarded. So we'll try to bring up the clients now. So before that, let me check the device fingerprinting show command. Since the clients are not up now, there is no client information is available for tracking. We'll try to bring up the end clients now. So we'll try to unshare the end client connected ports now. So we'll see the client details now in the other tab. If you could see here, the client is now placed first in the quarantine rule. The reason being is the Clearpass is not aware of the client details, so it will try to push only the quarantine VLAN for these end clients. So now we'll wait for the device fingerprinting data to be updated for these end clients. We'll go back to the switch console and check whether the device fingerprinting data is available for the end clients now or not. So client device fingerprint information will display it. So now both the end clients DFP data has been populated. So these are using the LLDP information now. The other client was using the DHCP. So now let's see whether the client has been correctly placed in the device specific role. So now the client switch ports has been bounced because the accounting information has been received by the Clearpass, and Clearpass would know what type of end device is connected. So it will trigger a radius COA action, and after the radius COA action, the client connected interfaces will be bounced. So after these client connected ports are bounced, they will try to onboard newly and they will get placed in the device specific role. For example, AP in the AP DUR, phone in the phone DUR. Because the Clearpass would have received the correct information to fingerprint the end device and it can able to propel them correctly. So let's check the device fingerprinting information again in the switch. So that information is also present here. So as we discussed earlier, there will be a COA message needed to trigger the switch bounce port. We'll check the show radius dyno authorization show command to check the COA request and acknowledgement. So you can use this show command to identify whether COA request is received or not from the Clearpass policy manager. So let's check the show output now from the Clearpass policy manager. So here is the request detail. So first for the Aruba IAP. So the AP is correctly profiled and now placed in the AP specific profile, and there is accounting information also received for this AP port. So we'll go to the previous request of the AP. So here is the first request of the AP. If you could open this request, you can identify the COA action as well in this. So there is a radius dyno authorization tab. So it will clearly show that there is a radius dyno authorization message requested for this end client. And then the status of the COA message as well. So this is the first authentication request for the AP, and then the AP was pushed only in the quarantine DUI profile because it was not profiled correctly. Let's close this and go to the accounting page. So here is the accounting logs for the end clients. If you could open the accounting log, it will clearly show the DFP data received from the end client. In the details tab, it will show the DFP data. So what is the AV pair received from the switch? So for the AP, we have received two AV pair. One is the DHCP option and other one is the LLDP data. So by default, this accounting log will not be displayed in the accounting page of Clearpass because this is an interim update. So for that purpose, we have to do this configuration in Clearpass. We'll go to service parameters and radius server. Here there will be the option log accounting interim update packet. So it has to be set as true. So only then the interim accounting packets will be logged in the GUI of the Clearpass Policy Manager. Here are the list of additional resources required for these features. Foremost is, if you wanted to understand how a DFP feature works, you can watch this video. Next is, this feature content has been integrated as part of 10.12 security guide. So you can refer more details about this DFP integration feature in this security guide. So thank you everyone for watching this video. If you have any further queries, you can reach out to us in our AREDS community. See you all. Bye.